This is the NEET 2013 question on the concept of friction. Interesting, and a lot of concepts are involved in solving this. So we can revise friction while you are talking about solving this problem. The upper half of an inclined plane of inclination theta is perfectly smooth, while the lower half is rough. Let me try to draw a diagram that what he meant to say, right? So there is an inclined plane like this of an angle of inclination theta in such a way that if the entire inclination is L, inclination length is half the length, it is smooth, remaining half the length, it is rough. It's what being said. A block starting from rest from the top of the plane, a block starting from rest at the top of the plane will again come to rest at the bottom. So what he is saying is, a block is started here. His initial velocity equal to 0. By the time it comes here, it acquires a velocity v. It is smooth, so there is no friction involved here. But after coming here, frictional force starts opposing it, and this velocity will be reduced. And finally, it came to the state of rest. That's what he is saying. Coefficient of friction between the blocks and lower blocks, mu is how much is the question that he is asking. So the first thing that I need to know is, I need to explain to you is what are the forces acting on the block at any of the instant, right? So when the block is here on the upper part, assuming its mass is m, its weight always acts in downward direction. Being this angle of inclination is theta, this angle also becomes theta, and mg can be resolved as adjacent component to that mg cos theta, downward component mg sin theta. So in the upper half, there is only one force acting down the inclined plane, that is mg sin theta. So what I can write? Upper half, no friction because it's a smooth surface. F downward ma equal to mg sin theta. So acceleration of that upper part is a equal to g sin theta. A is g sin theta, it is falling a distance L by 2. It will acquire some velocity v. How much is that? We can calculate, right? So for upper half, I can use an equation v square minus u square equal to 2as. We let it be v, that we don't know, but initially starting from the state of rest, u equal to 0, a equal to g sin theta, s equal to L by 2. So we got a equation for the velocity after crossing the first upper half, v square as 2g sin theta by 2 and L by 2. That's about the upper part. Let's come to the lower part now. This part. How this is different in the lower part is, I will draw that lower part diagram separately for you. For lower, I'll draw the diagram so that I can explain comfortably. There is a block here, M, angle of inclination is theta. So weight mg acts downward similarly, which can be resolved into components as this angle is theta. We have solved so many times this in friction that this angle is also equal to theta. This becomes mg cos theta. This becomes mg sin theta. So mg sin theta is the force that is pulling the block down the inclined plane. But this is not a smooth surface, this is a rough surface. So there's a friction. As the motion is in downward direction, Frictional force opposes the relative motion, so acts opposite to the motion along the inclined plane. How much is that frictional force is? Mu into normal reaction. What is normal reaction? mg is resolved not only as mg cos theta. So the normal reaction will be mg cos theta is the force applied by the block on the floor normal to the surface. So normal reaction here is the same in opposite direction, mu mg cos theta. Now I know the frictional force. I can write a resultant equation for the motion in the lower half, right? So what we can write? While the body moving along the lower half, we can write F resultant as F resultant is downward. You can very clearly see. So the force along the direction of the motion shall be treated as positive. Force against the motion shall be treated like negative. So force down the motion is mg sin theta minus against the motion is frictional force. So F resultant is ma is mg sin theta minus frictional force is, as we have already explained, mu mg cos theta. So m can be cancelled. Acceleration is g can also can be taken common in both this, sin theta minus mu cos theta. Notice that carefully, on a smooth surface, acceleration is only g sin theta coming down the inclined plane. But on a rough surface, acceleration is g of sin theta minus mu cos theta. Probably you have already derived all these things in your classroom. If you know, you can just skip the part of this derivation and go to the problem itself. Therefore, for the lower half, again, for the upper half, for the lower half, I can again use the equation v square minus e square equal to 2as, like I have used in the upper half. What happens in that case is, when I use it in the lower half, yeah, v square, it is being said that it is finally came to the rest. So v equal to 0. U means velocity here because you are talking about upper half. Here velocity is, we have already calculated it as v, this v, whatever we have derived. So v square 2a means we have already derived equation g sin theta minus mu cos theta. S is L by 2. Be careful, this v is not final velocity. This is the velocity acquired by the body after covering the upper half, right? So minus v square equal to 2g L by 2 of sin theta minus mu cos theta. I need to find out mu. But from the first part of the problem, I have already calculated v square. I can substitute that here, right? So from equation number 1, minus 2g sin theta L by 2, because this minus is there, minus I have kept. I have written what is the value of that v square, 2g sin theta L by 2 equal to 2g L by 2 of sin theta minus mu cos theta. I need to calculate that mu. 2g L by 2 on the left hand side and right hand side can be cancelled. What is remaining is minus sin theta equal to sin theta minus mu cos theta. Take this mu cos theta to other side, becomes positive. Take this minus sin theta to other side, that also becomes positive. That is 2 sin theta. So mu equal to sin theta by cos theta, that is tan theta. Of course, there is a 2, right? 2 sin theta by cos theta, that is 2 tan theta. So your answer for the mu is 2 tan theta. That's what you are expected to find out. That's what your answer is. Answer C is the option for this problem. So though the problem looks like a little lengthy problem, it's lengthy on the paper, on my paper, because I have derived this equation. acceleration of a body on a smooth inclined plane. I have also derived for the acceleration of a body on a rough inclined plane. If you remove that parts, problem is actually simple. I have only made it little lengthy to explain the concepts. Therefore, you will be learning all that, right? So for the upper half as well as for the lower half, I have only used equation v square minus c square equal to 2as. That's the actual part of the problem. And I have calculated a in the upper half, a in the lower half as this, and substituted those values in the given space so that you got your answer. That's how you have to solve this problem. Thank you for watching.